All right. I think that we are now live and recording. Hi again, Moein.
Hello, how are you?
I'm doing great. I'm doing great. So it has been almost a month that we recorded the last video, and the reason for such a delay is obviously your internship and mine. Mine fortunately came to an end, and yours, I guess you still have 1.5 more months to go, right?
Yes.
Okay. All right. It could
Yes.
pass soon. It could pass soon. But during this 1 month, a lot of stuff happened. A lot of cool models came out as expected. A lot of cool applications were introduced, and we have again a few interesting things to talk about. I didn't note too many things that are directly related to medicine, but I did note a few things that might be interesting to introduce today. And I also have several small topics to talk about, or maybe to put on people's radar. But as we were just talking about it, I don't think that our today's conversation is going to be as long as the previous sessions, right?
Yeah, I agree. Most of the items I have on my list are not that health related. Maybe one or two of them directly related to health in AI, but and mainly I'm going to introduce just some concepts and ideas and some
Mhm.
tutorials, some blog posts, so that people can follow the topic and read for themselves rather than just diving deep into in this episode.
Perfect, thank you. And I believe one of the most important checkpoints that happened during the past month was that Google event that was held. A lot of cool things came out of that. So, what was the name of the event? Was that Google I/O? Google I/O.
The
Google
IO
I/O.
event.
Right. Okay. Yeah. So if people are interested to figure out what were the main things that came out last month, I believe there are lots of good YouTube videos that have covered everything about that event. A lot of
And
cool models came out, and I guess one thing that we can talk about was MedGemma. I'm not sure if they officially introduced it then or it was released a little bit beforehand, but I'm pretty much sure that I heard MedGemma from that event as well. So
yeah,
let's
it was. I think it was mentioned in one of the slides in the
okay,
events. But yeah, I saw the main release of the model a few days after the event. So
yeah,
I'm not sure. Maybe it was released afterwards. But yeah, Google also itself has a blog post about all the things they mentioned and
sure.
released on that event. So I think one of the good resources to follow is Google Developer Blog or the Google blog itself, where they introduce all the
Well,
creative tools and all the research tools they have introduced, and there were a lot of them.
there were a
And
lot of
people were joking that many startups today are just some bullet points on the slides of the Google events.
yeah. And the good thing is that you actually introduced me to this. I wasn't aware of that, but Google is now providing, or at least providing, a free 1 year access to students or people who
Mm.
actually have access to educational email accounts. I am not sure if they're still doing that, but if there are some people here in the US or anywhere with an access to that edu email, they technically can have 1 year of free Gemini Pro account, which I believe is insane because Gemini is so powerful, much better. I mean, not necessarily better, but at least on par, and in many areas better than other state-of-the-art models, like the ones that you get from OpenAI or from Anthropic. So definitely give it a try if you already are eligible and have that edu email accounts.
Yeah, and as we were just discussing the Google's superiority in many fronts in the previous episode of our podcast, and the event happened just
Mhm.
probably a few weeks after that. The advantage that Google has in this area and in this technological scene is that they have already a good stack of software in place that people are using day to day, like the Docs, the Google Docs, and the spreadsheets. And this Gemini gets integrated to all of those services and makes it
Exactly.
much more enjoyable to use those products as well. Even in the Gmail itself, you can,
Mm.
instead of just copying and pasting or using extensions, now you can just press Option and H in the emails so that it polishes and it restates what you wanted to
Really,
say, approves it, and yeah,
I haven't
it's
tried it yet.
much,
The
yeah.
main reason is that I'm nowadays mostly using Outlook to manage multiple email accounts, but hopefully they will also integrate something like that. I wasn't aware that Gmail has provided such a capability to polish your email inside. This is nice. This is nice to have.
Yeah.
But
Yeah.
yeah, go ahead.
I just wanted to say that this integration of AI into the tools we were already using just doubles the productivity of everything we were doing. So
Mhm.
nowadays I'm less using ChatGPT or Claude. I mean, I've stopped basically using Claude, and I was a pro ChatGPT user, but after this event and getting the pro account of Gemini for a year. Now I'm basically doing everything in Gemini, even for image generation, and basically, yeah, you can get, and there is also a notebook LM which you can use for basically free now.
Yeah.
There are lots of good products, and Google is doing a great job in this scene.
Yeah, they definitely are doing a great job. And you literally scratched the surface of a discussion that can go for a very long time. But I have also been giving a lot of thought towards what kind of LLM provider service I should use. Because at the moment, I'm honestly paying not the max subscription, but the pro subscription for OpenAI, Anthropic, Gemini. Thanks to what you introduced to me, is now coming free. But all of these things, and I'm thinking that is that the best way to optimize that? Do you need to have all of these things available on your arsenal, or maybe you can go from all of these to only one account, like an OpenRouter account that gives you access to multiple different models, or maybe just cancel everything and go with something that go with a max account in one of these providers. Say, for example, you go with Cloud Max, and then it will also give you access to Cloud Code for free. Or maybe you go with, I mean, OpenAI Pro account is so expensive. I mean, that is off my radar
Yeah.
right now. $250 per month is not something that I'm happy to give. But so these kind of questions are kind of crazy. I'm not quite sure what to do with those, but that's also kind of interesting and exciting, because every month these providers come up with something new that you say that, no, let's just pay more month of subscription fee and see what comes out of this thing. So yeah, I don't know what to do with all of these different models. And what I ended up doing is that I'm every now and then using all of those to just see what new features they're offering. And I have not yet been able to convince myself to, just say farewell to a couple of those and only stick to one. I'm not sure if you have managed to do that or not.
Um, as I said, I'm basically using Gemini for everything these days. I really like the style of the responses and prefer it over the how ChatGPT responds to your questions. And I feel like ChatGPT always wants to teach you something moral
Yeah.
and tell you that what you said may not be the best thing you could say or ask or something like that. But Gemini is very to the point, and
Yeah, they're
I
doing a
really,
great job.
I really prefer the style of the
Yeah.
responses, and also the deep research of uh,
Gemini is
Gemini.
superior.
Yeah, I really like that
Yeah.
it goes through lots of resources and gives you a complete report. I used to use deep research in ChatGPT first, but I stopped using it because it didn't come up with with the ideas or the resources I wanted to check out. But Gemini, most of the time, takes care of everything I wanted to look after.
Cool, cool. Yeah, I should probably prioritize using Gemini 2.5 a little more. Uh, in a few instances that I tried, that even the 2.5 Flash model was doing a decent job in answering most of my day-to-day requests compared to the Pro one, which you can also use for more powerful and more compute-intensive kind of tasks. But anyhow, so that was just a starter, and because we started with Google, let's actually talk about a few things that came out of that. And the very first one that I'm pretty much sure that everyone has heard about, if people went through that Google I/O events. But if not, I'm just going to quickly review. And Moin, please confirm if you're seeing my spreadsheet now.
Yes.
Okay, so this was this VO3, and I'm pretty much sure that you heard about it. And I guess that was kind of a game changer. Let me open the link. So long story short, Google introduced a new video generation model, and they call that VO3. And this is insane. I mean, the videos that this model produces for you And I don't know if people are now watching with a reduced frame rate because of YouTube adjustments or not, but if just go and search VO3 and look at this website yourself, the quality of the videos, the details of the scenes, and the simple addition that now your videos have audios, I mean AI generated audios and dialogues on top of it. That is insane. I mean, you can just scroll through it and see the different videos that it has generated. And can you imagine that this entire scene with the cat itself and all these musicians in the background, they're all AI generated. So I believe this has a lot of implications, not only for the art industry, movie industry, but even in medicine, because now, and even in education, because now you can actually, I mean, if you can think of something, you can generate it and you can create it. Now, definitely it is expensive. I believe with Gemini 2.5 Pro, you have a limited access to generate 8-second long video clips, but this kind of limitations will easily go away as we go forward and these models become cheaper and cheaper. But right, I mean, you have lots of power to just create whatever you like, and who knows what kind of impact this kind of video models could have. So that was the first thing that I really wanted to bring it on in case somebody has missed it, that this looks like to be a very, very revolutionary model from Google that came out.
Yeah, and also I think one thing that's happened with video that's many people were pessimistic about or didn't actually expect to happen this soon was that the quality of these generations, I mean, are beyond the expectations of what we thought AI would be in 2025. I mean, I still remember the talks from Jan LeCun saying that AI will not be able to solve video for a long time.
Yeah,
And I think that is at least falsified as long
yeah,
as we know.
yeah,
And the thing that you mentioned is also very important, that basically whatever we can imagine in art right now, there are tools that make you as a non-artist person capable of making that art. I mean,
creating, yeah,
there's also another tool introduced in the I/O event called Flow, I think.
yeah,
That was for directors and video makers and professional video
yeah,
makers. That helps them to make an scripts and make a flow of the scenes that they can imagine, which basically could make a movie.
yeah,
And I think we are not that far from seeing totally AI generated Hollywood movies or movies in that quality. And this is something I really didn't expect to happen this soon. And
yeah.
the qualities are really, I mean, groundbreaking.
Yeah, exactly. So I'm trying to find a couple of demos from Flow. I believe this is kind of a demo, and then I'm not sure how much of this is kind of probably output of the Flow that people have generated, and it is now available as a demo for people to see. But now you can also see that the prompt that people put in: 360 video, tiny city planet, tiny around city urban, a giant ostrich, and then you see that this is great, right? I mean, you just
Yeah.
go through it, and with 3 lines of prompt, you can generate such videos. This is amazing. This is
And
quite
then,
amazing.
yeah, you
And
can describe how the scenes change and merge into each other, what should happen next. And then, I mean, this is really changing the way we see art and we perceive
yeah,
art. That's really good.
oh my God. Okay, yeah. So this was kind of a general product from Google, not necessarily specific to medicine. But then we can talk about MedGemma, and then MedGemma was a model that came out of Google, and this is a Gemma 3 variant optimized for medical text and image comprehension. Now I'm trying to introduce this. I will try to introduce this briefly, Moin, but I know that you probably have uh, dig a little bit more into the details of that. So feel free to interrupt me or just complete me wherever you like. But uh, based on what I understand, MedGemma is technically a fine-tuned version of Gemma 3 on medical data. And they have released 2 versions of this model, one 4 billion and one 27 billion. Let me zoom in a little bit. The 4 billion version is actually multimodal, technically meaning that it can interpret text and image at the same time. and the 27 billion parameter model is text-only model. So they have two different versions of this available. Now, a couple of things regarding these models. First of all, Google has released tons of information and details regarding these models, which itself is valuable because now you have access to a very detailed model card that gives you information and very clear details of how this model was developed, what kind of licensing it has, how you can use it in practice. And if you're a coder, for example, this is the way that you can use it with the transformer library, which is for Hugging Face. And then they provide examples of how to use that. And if you scroll down, for example, you can see that, all the data sets that were used to train this model, say, for example, the mimic chest X-ray data set, which is a famous data set for, chest X-rays, and it has both imaging and reports available, and some dermatology images, some pathology images, and then you clearly know what data this model has been exposed to, and then you can just grasp this model and fine-tune it further for whatever task that you have. And it is freely available. You can just download it. So it's a matter of you having access to the hardware to train it and run it. But it technically doesn't come with any kind of provider blocked or owner blocked kind of restrictions. The only thing that you should have in mind is that the license is Apache 2, which is still a very generous license. But apart from that, everything else about this model, you can easily access it and work with. So it's a very powerful family of models for academic purposes and people who want to do research or people who actually are concerned of not leaking their sensitive data to these commercial models. So they can easily go with MedGemma, and then technically they have access to a very good model on trained specifically for medical data. And I cannot currently find where they actually talked about their benchmarks, but the benchmark was also quite good. I believe they compared that to technique. I guess this is part of the benchmark that you can see, I believe. So on the data sets that they trained on, so you can see it here. I mean, they also reported performance on some unseen kind of tasks as well, and they compared it with the baseline version of Gemma 3. And I guess this is the table that they talks about that. And you see that, for example, the Gemma 3 27 billion parameters without being fine-tuned as MedGemma has an inferior performance on these data sets compared to the MedGemma that is now more of a medical tuned model. So that was a very generous contribution from Google to the world of medicine. Again, something that we can talk about and hopefully wait for very creative applications of to come out in the next few months. But we do not have access to such great models from Google, only for medicine.
Yeah, and that is a great contribution from Google. I really like this approach of Google to how a line of business models that they don't release the code or the technological reports behind them, but they also have this line of Gemma models that are open weights and free to use. And yeah, this fine-tuned version of Gemma is also going to be very useful. I'm still thinking that the most useful form of even MedGemma is those fine-tuned versions for narrower tasks, because I'm still a bit, I don't know, pessimistic or just not very used to seeing that a 4 billion model to be able to do many of the tasks in medicine with good accuracy. I think we still need to have other or just maybe bigger models for in the stage that we can say this model can do many tasks at the same time with a good accuracy. I think we're still not there yet, but definitely these models could serve as a good base model to be trained, to be fine-tuned, and used for a bit narrower tests, at least for radiology, not just for radiology, oncology, and dermatology. That would, I think, it's that's a lot to ask from a single model at this point with 4 billion parameters. I could be mistaken here because I've not used them or seen a comprehensive benchmark on these models, but I think we can expect that these models won't be that
Yeah.
accurate on every task in medicine.
I also agree that probably a single model, whether it is 4 billion parameters or 27 billion parameters, will not be sufficiently powerful to tackle all the problems that we wanted to solve. But we are now also in a world of agents. So I believe that maybe if you have a group of models that are tasked to do something, and then each of those models are technically using a fine-tuned Gemma with 27 or even 4 billion parameters as their core brain, then the collection of those agents might be able to achieve something that a single very powerful model is not able to do, or maybe does it, but at a very unreasonable cost. So I guess if we just put these MedGemma models or Gemma models or all of those open source, open weight models in the context of an agentic context, then they might make more sense. But I agree, if you really want to, do a task that is complicated with a zero-shot performance, then definitely one of those commercial, more powerful models, or even Gemini 2.5 Pro that comes out of Google, for example, that is going to be certainly more useful than any of these models alone.
Yeah, and I really like that basically all the tasks, at least we know in the computer vision area of tasks in medicine, are coming into a unified framework called these VLMs or LLMs that can generate tokens, and those tokens could be coordinates of a bounding box. Those could be the pixels that make a segmentation work, or could be just classification. And I think this is a good sign that we are getting to a convergence of architectures and use cases. And maybe we are not that far from those AGI vibes that people are advertising these days, but this was something that needed to happen, and it's really interesting to watch it happen.
Yeah, exactly. I mean, if you remember throughout the past couple of months that we actually reviewed these new advancements every month, we kind of felt that as we go forward, the models that are introduced are more and more capable of handling more than one task with a very reasonable performance at the same time. So they are becoming more multimodal, they are becoming more multi-purpose, and then when you have a couple of these models at your arsenal, then you can certainly just focus on the task that you want to do. Your kind of attention moves from developing the model or finding the best model to using these great, powerful models for the application that you have in mind. So it's kind of a shift from model management and model building towards application management and application building, which brings us to one of the conversations that we had a couple of sessions ago, where we talked about, domain expertise is still very important, because if you have a basic understanding of AI and you know that these models exist and you can one way or another use them, even if you cannot use them directly because you are not a programmer or developer, you can actually communicate reasonably and efficiently with a team of programmers or developers to work on your behalf, then you have unlimited power to develop whatever application that your domain expertise is recommending you to develop. And that is insane. That, in my opinion, is a very powerful weapon that anyone can have. And if you're interested in whatever academic purposes, in whatever private purposes, commercial purposes, technically have the gun to go and nail all of those goals at the same time. You just need to know what tool to use and what applications are now ready to be built. And that is a crazy world. I like it. I really like it much more than the time that we were just building individual models and tediously fine-tune them and tediously evaluate them for single task purposes. And we kind of knew that at the end of the day, these models are not going to be that useful.
And we knew that all these tasks share some knowledge that would be relevant to the other models' task, and we didn't, or we couldn't find a way to relate these models together. And now it makes just much more sense to train a base model on everything medical we can get our hands on, and then use that. And if we have a really narrow use case that we want a very good model for that, we can go on and fine tune one of these using and leveraging all those knowledge that we had from pre-training on a large corpus of medical text into that narrow task. And I think that is really valuable and wasn't possible just a few years back.
Exactly. Anyhow, so this was a MedGemma family of models. Go and explore it if you like. And speaking of new models, a few others also came out. So Moin, if you don't mind, I can very quickly go through them. Probably do not worth to spend too much time on it. But one of them is DeepSeek R10528, which I believe came out 1 or 2 days ago at the time of recording this video. And this is a new version of DeepSeek, and the way that they improve the performance of it is kind of interesting. They didn't train a new model. That is the DeepSeek R1 model that came out a few months back and basically drove the entire world crazy. But what they did recently is that they kept aligning it using reinforcement learning, and they achieved even better performance. So I'm not sure if I can show this chart with readable captions to you, but technically what this is saying is that this dark blue one is DeepSeek R1, and then we have OpenAI O3, which is their state-of-the-art model, Gemini 2.5 Pro, and one of the open source versions of that, Qwen 3, and then DeepSeek R1, the old version. And you see that almost in across most of the benchmarks, the DeepSeek R1, which is an open source model that is not behind paywalls. So that is comparing to the best models that we have from commercial providers, from Google or OpenAI, and it's doing a great job. And again, the most important thing that people are talking about at the moment is that it is another proof and evidence for how reinforcement learning can make models better. And some papers also came out on the topic of reinforcement learning that is somehow relevant to what DeepSeek did. And they were just showing that, nowadays we know more and more, and we are getting to know more and more that reinforcement learning is not teaching new concepts to the models. It technically is just unveiling their power, whatever they learned throughout their main pre-training, and let them use it more often and in more appropriate occasions. So reinforcement learning is kind of like, removing the noise from the knowledge of a model and letting it use the most essential information that it has learned for whatever purposes that the user has. And DeepSeek did it again, showed it that without needing to train a model again, you can still improve its performance very significantly, basically from this light blue to this dark blue, and beat a couple of commercial models in between only by reinforced learning of your model on a bunch of new data, but without changing its knowledge. So that is kind of interesting. And again, it's good to know that the open source community is moving on par with the commercial models, and we have another model available that we can use and experiment with.
Yeah, and I don't know if you feel the same way, or is it just me that one of the things I really feel that I missed out on this maybe last 1 year of AI was that I really underestimated the power of RL, reinforcement learning.
Yeah.
And now I'm really feeling the need and the necessity of learning it and being good at it and understanding its core basic concepts.
Yeah.
And I really didn't expect that it becomes an undeniable element of today's models.
Yeah.
And I think most of the people in the community were thinking in the same ways after, again, maybe the effect of Jan LeCun's criticism of RL and the famous cake example that says that if the whole intelligence is a cake, the cherry on top would be the impact of RL, which I think now is not that helpful. Is not a helpful analogy in these days. And I really felt the need to learn it, and for that, maybe it helps to mention it here. I was considering starting the Hugging Face course on reinforcement learning, which was on their list of. They have released a few new courses on MCP, on reinforcement learning, and I think this one maybe would be a good start.
Okay.
I really like the Hugging Face courses because they're real to the point, and there are also so many good resources so that people can dive deeper into if they want in their own time.
Yeah,
And I think this would be a good start to learning more about deep RL.
awesome. And Moin, help me to navigate to the main Hugging Face course page, because I guess that you wanted
I
to
think
introduce
you
that
can
one.
click on that under the Hugging Face logo itself, deep RL course. There
Okay,
is a
and then you
drop
can
down
see all
here.
resources. Okay, there we go.
Yeah, all of them are here. The MCP course, LLM course, deep R agents course.
Yeah, very, very rich collection of courses here. But I
Yeah,
think most of those are for developers, right? So you need to have a little bit of
yeah,
development
yeah.
knowledge.
Most of them require some basic understanding of how deep learning works and a familiarity with coding and with PyTorch.
Yeah.
Or if you're not a expert PyTorch coder, it's still okay because most of them use Hugging Face libraries and they're really easy to use and user friendly. So yeah, if you're a good Python programmer and you can code for yourself, you're okay to get started on
From
one of those
here and
courses.
learn from it. Yeah, this is very interesting, and I really like it. And I guess that's a very nice course. I mean, this one just attracted my attention, but all of those look very good. I mean, if you want to learn about diffusion model, for example, I guess they again put together a very nice collection of content here, and they talk about the stable diffusion, everything. And I guess most of these have codes in addition to content, right?
Definitely.
So you can
Yeah,
basically just write them hands-on.
yeah. There are accompanying Jupyter notebooks and collabs
Cool.
with all of these courses, and makes it really hands-on and enjoyable.
Awesome. I like it. That's great. And again, I believe if people have time, they can just come here and explore it a little bit and learn a lot from it. And again, Hugging Face also provides most of the models that probably are using for these courses is free as well, so you can play around with those models as well. Very interesting one. And the other topics about models that came out obviously was the cloud new version of models, the cloud v4 and cloud opus and cloud sonnet v4 that I didn't include here because I thought it would be too much talking about the new models, but that is also something that came out, and people are mostly using that for the sake of coding. For these code developers, code editor IDEs that use AI, most of them integrated those models as well. So that's one thing that if you are into coding AI, you can have in mind. But anyhow, the last model that I want to introduce, which kind of caught my eyes, was this one. And this is just an example of a family of models that I didn't have that much on my radar, Moin. You probably have heard about those, but that was the first time that after a long time, I came back to this topic, and that is the topic of models specifically designed for understanding tabular data and working with those, which is kind of interesting because, a lot of the data that we have in the world, maybe not as much as the free text data that we have, but still a very significant portion of that is actually present in the format of databases and data sets. And even, many of us who just work with custom data sets that we have built for our own research, or, throughout the time, we have data that just is sitting there on an Excel spreadsheet or a Google spreadsheet. And it would be great if you can apply some models to them and see how those work. I do remember maybe from 2 or 3 years ago that there were people working on those kind of models, and we always knew that deep learning, at least on that time, was not on par with conventional machine learning when it came to understanding tabular data. But it seems that now the new family of models that are coming to the market, and they are also transformer based. They are technically large language models. They can take care of understanding tables very well as well. So we kind of saw that with the PDF understanding capability of models like Gemini, but now we are seeing models that are specifically built for tables, and who knows, maybe in a while can be integrated into Google Spreadsheet or Microsoft Excel, and then you can actually use them for inferring what data or what insights is hidden within your tables. This one is basically introducing a new model named Table R1, which I believe is kind of a fine-tuning of DeepSeek R1 model. They used supervised fine-tuning as well as alignment with reinforcement learning, I believe. So again, a comparison of both of them. And they are reporting relatively acceptable performance, at least compared to the models that have a very powerful commercial backgrounds. And yeah, I just wanted to also introduce this one. And using these models, you can just go to a table like this, an Excel spreadsheet or something like that, ask a question, answer the question based on the provided table. What was the total number of points scored by the Tide in the last 3 games combined? And the model can directly tell you the result that is needed. So this is kind of interesting use case that I believe we are not leveraging the current AI models that much for, but hopefully in the future we can see more of these models coming out as well.
Yeah, and yes, tabular data has always been a totally different animal in these all the data sets and data structures that we have been working with in AI. And they were, as long as I remember, most of the time I was hearing something about deep learning doing something in tabular data. There was some other guy saying that, okay, XGBoost or CatBoost, which are methods in more classic machine learning stuff, will beat these papers results, and it was some area that deep learning wasn't doing very well at, and it was kind of difficult to understand exactly why. There's many good explanations on why deep learning can't do well in this area, but maybe these LLM based solutions are the way to turn that around once and for all. And I hadn't heard about this, and thanks for mentioning it. It's really cool to see that LLMs and reinforcement learning are also helping in this area as well.
Yeah, I agree. And it also kind of implies the previous discussion that we just had about it seems like that LLM is kind of dominating in most of the use cases that people have had in the past. And in some of them, they believe that deep learning is not that much of a winning card. But now we are seeing that, as far as you have a good model and as far as you have some good data for fine-tuning or aligning your model on it, then there is no task left that your model cannot reliably perform for you. And it again brings us to the question that how are we going to use these powerful models? But anyhow, so this is also an interesting paper if people are interested to learn about it. And I guess they also have released the code. I'm not sure about the model, but at least, I guess the model is also available on Hugging Face. So if you want to give it a try, feel free to explore their Hugging Face and GitHub pages. And Moein, I guess that was the last new model that I wanted to introduce. So maybe that's a good checkpoint for me to pause and hand over the scene to you so that you can go ahead a little bit, and then I can come back and talk about some other topics if you like.
Okay, definitely. And thanks for sharing. Let me see. Okay, I will start with some blog posts and short topics to introduce, and then maybe dive into one of the papers that I wanted to introduce. Okay, let me share my screen. Okay, I think you should be able to see it now. Yeah, because you were speaking of DeepSeek R1 and the paper and the methods they were introducing, I wanted to introduce this interesting blog post by, I think if I pronounce his name correctly, Kirill Zakha, who's a medical doctor and also a machine learning engineer, I think currently at Hugging Face.
Awesome.
I really like his works and his projects that he's sometimes share on his Twitter account. And he recently wrote this introduction to PPO and GRPO, which are RL methods to post-train many of these large language models. And GRPO was introduced in the paper before DeepSeek R1, which was the thing that's really helped these models to reason better and made them work by just applying some reasoning steps to coding and math, which was at the time if making a lot of noise. And the math behind it was and is definitely very difficult to understand. And this blog post dives deep into that. And I wanted to mention quickly
Okay.
when you mentioned the
Is it easier
technical.
digestible than the paper itself, so you can go through it and understand what they have done?
Yes, I haven't gone through it completely, but it's
Okay.
much more understandable than
Than the
the
paper.
short
Right?
introduction in the paper itself. So
Yeah.
yeah, and
That's okay.
there's also a whole, based on one of the references in this blog post, I found that there's also a whole book on reinforcement learning from human feedback from Nathan Lambert, who
Mhm.
is very knowledgeable in this field. Again, based on his Twitter account, he's very active on this topic, and there's this online version of this book available for those who want to dive deeper into this topic. And okay, let me uh, also cover a few things from the Google announcements. There's also this Gemma 3 Nano version,
Yeah.
which is used for on edge devices like mobile phones. And the cool thing about this is that they mentioned these models use a DeepMind innovation called per layer embeddings that delivers a significant reduction in RAM usage, which is makes it very usable for limited devices like mobile phones that do not have lots of RAM capacity. And they say that while the raw parameter count is 5 billion and 8 billion, this innovation allows you to run larger models on mobile devices to live or live stream from cloud. And the memory overhead will be just for a 2 billion or 4 billion model, which makes it really usable. And this chart here is really crazy. I think that a 4 billion parameter model now is being compared to Claude 3.7 Sonnet, which is a
Yes.
much larger. We don't probably know the exact parameter count, but the performance is on par or comparable to that model. And I really like this trend of going into smaller and more compact but powerful LLMs that could just be fit on a single GPU and now on a single mobile phone. Yeah, it goes deeper into the technical nuances that made this possible. And I think I really like this family of Gemma models. I think
Yeah.
they're very usable. And
They're really
apart from the
interesting.
business class of their models, which is Gemini, I think these are very useful because they can just be run on a single machine.
Yeah. So, Moin, I do have an iPhone application named Pocket Pal that
Hmm.
technically gives me access to many local LLMs. Just wanted to introduce that. It's kind of interesting. I mean, from time to time, if you just want to work with an LLM and you really don't want to, share something with a commercial provider or maybe pay for something, this is kind of cool. This app provides access to most of the models that you really want to work with. I'm not sure if they have the Nano version available here as well or not, but I'm also not sure if my app is that up to date. But anyhow, so this is, I mean, I guess there are some applications on iPhone and Android that technically enables you to work with these models even right now. So give those a try, and you will feel like that these are not as, these are not really different from ChatGPT or other models, unless if you have a very complicated use case. For the day-to-day tasks that most of us have, these models are as capable as those commercial models, which is crazy.
Yeah, definitely for day-to-day questions, they are, I think, more than what many of us would need for general questions.
Yeah,
And for more complicated ones, we can always refer to the Gemini or O3 models of ChatGPT.
yeah.
But yeah, this was also a cool introduction in the event. Um, Going from Google to OpenAI, I had this one to introduce the HealthBench.
Oh,
Yeah,
love
the
it.
benchmark from OpenAI on healthcare, which I was still a bit some doubts about it, but this
Mm,
is a very necessary benchmark to how after the release of all these agentic systems based on LLMs that could make many mistakes in answering, and just having a framework of how to evaluate and have some questions and some answers to evaluate these agents on is really important and
Yeah.
valuable. They introduce it like this. This HealthBench benchmark is a new benchmark designed to better measure capabilities of AI systems for health, with partnership of 262 physicians from 60 countries, includes 5,000 realistic health conversations,
Mm.
each with a custom physician-created rubric to grade model responses. So basically, there are conversations along with a set of criteria or some points that the physician mentioned that the AI system is good to mention those or not to do some things or not to say something in a way that is misleading.
Mm-hmm.
So this is the general architecture of each of the examples. And they say that based on these, then you can see what I was saying at the beginning that um, made me doubt the quality or usability of this benchmark. Is that HealthBench is grounded in our belief that evaluations for AI systems should be meaningful, um, and they define this meaningfulness in a way that it has real-world impact,
Mm-hmm.
uh, to set it apart from the USMLE exam kind of
Yeah.
questions that they're so technical and maybe sometimes not very directly based on a case, a real patient in a scenario that could seek some help from the AI system, and the trustworthiness, and it should be unsaturated. Benchmark support progress, and they wanted to make something new that is not available probably on the internet
Mm.
at the time. And I think seeing some of the examples would probably help.
Yeah.
And here is the first
Mhm.
interaction of the user with the AI. And as you see, the tone is like, I don't know how to say it, a general public, a not
Yeah.
medical expert asking a question. There are questions that are more technical and more with lots of medical terminology and stuff. But the style of the questions is, I think, more towards the general population. And as you see, this is a
Definitely.
normal, a non-medical person asking a medical question, and the answer, as you see here,
The answer is so funny. I mean, if you ask such an urgent question, do you really want to see a paragraph like why you shouldn't just wait? And then, I mean, you do want to see something very concise without any introduction, without any prelogue or epilogue, just saying, do this. Okay. And
yes,
then
exactly.
how it
Maybe just a flow
yeah, I mean,
chart or something.
easily.
Yeah,
This is
and
very
yeah,
ChatGPT like.
exactly. And my problem with this was that it's not that technical. It's like a general public thing, and you probably can't um, criticize or can't evaluate the medical usefulness of a model with these sorts of questions. These are, I don't know. I wouldn't put these sorts of
Yeah.
questions in a health benchmark or advertise it as a benchmark for medicine.
Yeah.
Yeah, I mean, I have some doubts about it. There are more technical questions, expertise tailored communication, I think. No, this is still very general. Um, Let me see. I saw one. This one asks for a progress note, or this one, yeah, this is asking a, very general
Mhm.
question again, as you see. I mean, I didn't exactly know how this, who is um, um, uh, the targets, or
Yeah.
what are the use cases of this health benchmark thing. Yeah. And as you see, the examples are kind of weird.
The examples
As
are weird, and as you said, it's not clear if it is a benchmark to assess the capability of these models for helping doctors or for acting instead of doctors to answer the questions from public. And if either of these are true, the questions and answers that at least we see on these demos are not perfect. I do think that this is a step in the right direction. Moving away from USMLE-like kind of benchmarks is certainly a good step, because what a doctor does, regardless of their specialty and regardless of the setting that they need to interact with medical data or from patient data, definitely is far different from just answering some MCQ questions. But this is still far from ideal. I mean, a step in the right direction, far from ideal. We do need much more complicated benchmarks if we really want to compare LLM's performance. Even as an assistant for a doctor, this is not enough. This doesn't look like to the job that I am doing day to day, you are doing day to day, or any other doctors is doing. So acceptable. Thank you, OpenAI, for going towards that direction. Far from ideal.
Yeah, I have the exact same concerns that I think they were probably mostly thinking about AI chatbots that are going to assist some patients to seek some advice, medical advice, but
Mhm.
not that technical advice. But when I saw the title of HealthBench and the way it was advertised in social media and everywhere,
Yeah.
I was thinking it's going to be a very technical medical benchmark that you can
Uh,
use to evaluate the medical knowledge of a chatbot or agent. But I think this is not the way
no, it's
that
not.
you
Yeah.
can rely on it. Yeah.
Yeah. And the thing is
So
that, the world of medicine is full of complexities that if you are trying to approach it just from an engineering perspective, you certainly are going to miss a lot of points. I mean, this can possibly be said about any specific domain, not necessarily the medicine, but at least from the medical perspective, I can easily say that this benchmark is lacking many, many nuances. And again, I give it to them that they are moving one step forward, at least raising the bar a little bit for these benchmarks that come for the world of medicine. But still, we have a long, long way to go to at least we can reliably, evaluate the models that come for the medical world rather than developing them. If you, for example, compare it to the benchmarks that we have for coding tasks, those benchmarks are much more mature, are much more to the point. And when a model does better than other model in a coding task, then you can nowadays reliably say that in most of the cases, that model is also going to be better in real use cases. But if you tell me that a model is doing better in answering these questions, can I reliably say that, okay, so that model is going to be ready for real use cases, or even the performance is going to remain as reliable in real use cases or not? I don't think that I can say yes to that question.
yeah, and I agree. And so this was just an introduction to this
Yeah.
new release from OpenAI. Let me see. Um, the rest of the things I have gathered for this episode, maybe you can dive into this one a bit.
Mm-hmm.
Um, the MedRouter, I like the idea, and again,
Oh,
there are some
yeah.
questions or concerns about how this project is going to turn out. This is called MedRouter, and I really was reminded of OpenRouter when I was
Yeah.
I heard the name, and I think it is inspired probably by that idea. And the concept here is that you don't need to run any of the medical models, deep learning medical models that you hear, like a total segmenter or any of these pre-trained models on your device. You can just use this system to send your data to get analyzed and then get the response back over API. And here is a list of models available for the API. As you can see, there are many different things, from MRI to vessel segmentation to CTS and the total CT segmentation model. And there are not that many for now, but I think the vision for this was something like a model hub, or every something like probably like Hugging Face, that anyone who trains a model could put their model here, and then people could use that over API.
Mhm.
And you can see that if I click on one of these models, it is fairly easy to use. You send your data, you select the model you want to use, and then you get some response back. But the problem with medicine is that you can't easily send your data over to an
Yeah,
API.
yeah,
And I'm not sure how they are going to find a solution for this. There probably are some safety measurements that could take care of this sending data over and get some response back. But I think this is going to be the first thing that people will ask in big hospitals or clinical institutions, that how can we trust you to send our data
yeah.
there? And
So they should explicitly mention that they are HIPAA safe. Have they said something like that?
I haven't said that. And I think this is not a big project by a company. This
Mm.
is more like a side project by some
I
person, because I saw their name on I think it was in the contacts maybe or something. Um, Now, this platform is not FDA approved and does not provide diagnostic services. So if it was HIPAA compliant, I think it should
Yeah,
be
I believe
mentioned.
they should have mentioned that. Yeah, as you said, the main bottleneck with such medical applications is HIPAA compliance, and I'm pretty much sure that if they want to, I don't know, sign a contract with the health institute, or become a partner of a big health institute, they need to deal with two issues at the same time. The first one, and the more important one, as you said, is the issue of trust. And they need to somehow guarantee that institute that your data is not going to be shared with anyone, or maybe even remain in your firewall or things like that. And the second issue, which is kind of uh, another bottleneck as well, is that they need to figure out a way to be integrated into the current electronic health record platforms that the hospitals have. Because if you, as a physician who are working in a hospital, are going to use their service, there is no easy way for you to simply download the patient data and then go to the internet and then upload the patient data here and try to see what the model is predicting for you. First of all, a lot of these kind of APIs are blocked by the firewall of hospitals and institutes. And second, even if you can do that, it's such a hassle, because you just need to go and download the data from the EHR that, depending on the EHR provider, might or might not be possible. And even if it is possible, then are you going to do this for every single patient that you have, to just go through lots of clicks, download it, and then send it somewhere else? So I believe the kind of viable business model for such a startups is to become integrated into Epic, Meditech, or all those EHR systems, or PAC systems that they have, which brings another question on that, whether those health EHR providers or PACS provider are ready to just integrate a production ready tool like this one into their APIs, or go and come up with their own version of these routers that are probably cheaper and that are probably safer to transfer the data to. So very interesting idea, and a very good one for research and trying and error on development projects. But I'm not sure how much it is going to be successful in real practice. I hope they do, because they're doing something valuable. But I do see a lot of problems in Bay as well.
Yeah, I think this idea of having a model hub for medical use cases was something that many people tried over the last
Yeah.
maybe 2 or 3 years, but we still don't have a good resource to go to if we want to start from some pre-trained um, model. Like, I mean, there was the library called Tim that
Mhm.
then integrated into
Yeah.
Hugging Face, that we were all using for computer vision pre-trained models that were mostly pre-trained on ImageNet or some huge natural image datasets, but having a good pre-trained models to start from for fine-tuning is something that is missing. Having a model hub like this that is able to process images on the cloud over APIs is still missing. And I think the main problem and challenge with all this is that this data safety is so important and something that can't be ignored,
Yeah,
that unless we have some solutions for that, we probably won't have a solution for this lack of pre-trained models and model hubs.
I agree. I totally agree. But anyhow, a valuable effort, definitely, for sure. And
Yeah.
thank you for your-
So, um, uh, so I think I stop here,
Yep.
if you agree, and then I
Yep, I can continue.
introduce the next ones after you. Yeah.
Perfect. Yeah, I guess I have 2 or 3 topics left to explore. And those are kind of interesting topics to go through. So let me share my window again. All right, so let's start with something that kind of blew my mind when I first read about that. It's not technically a medical paper, more of a general AI paper, but something that I believe has a very important implication for medical world as well. And that
It was
is,
on my list too, and yeah.
oh really? Okay, so this
Yeah.
is very interesting. So maybe the 2 of us can talk about it now. So for people who don't know about this is a paper that came out a few days ago, and it's talking about model embeddings. And embeddings, in simple word, is kind of a mathematical representation of different data types, say textual data, image data, video data, whatever, into some numerical forms. Say, for example, you have a series of 100 numbers that all together are representing a word or are representing an image. Now, the thing is that we do know that these embedding models are very powerful, and we do know that model embeddings have been the core technology behind RAG, behind a lot of different things that we are doing, even behind the day-to-day performance of LLMs. But what we didn't know so far before this paper came out, and now we know, is that the embedding models of different models could be converted to each other, which is a crazy idea because so far, what we knew is that if we really want to embed some sort of input data, and then later on use those embeddings to, for example, add a little bit of relevant context to another LLM down the road, or maybe just have another LLM to use that embedding for answering the user's question. The embedding LLM and the LLM which is going to use that embedding data should kind of be aligned, or at least they should be somehow relevant to each other, mostly coming from the same organization or from same provider, so that we know that we are using the embeddings, in a reliable way. Otherwise, the down the road LLM might not be able to understand what these values mean if they are coming from an LLM that is completely different. But what these people showed is that embeddings from different models could kind of be converted to each other. So what this means is that, and let me just read from it for you, given only a vector database, which is a mouthful for a collection of embeddings, from an unknown model. So say that you just figured out that you have a lot of embeddings available, but you don't know what these embedding models, what these embeddings are coming from, or what they're representing. Their proposal here, their tool, which is named Vec2Vec, translates the database into the space of a known model using latent structure alone. So technically, you can get that initial pool of embeddings and convert it to embeddings of another model that you know everything about. And this technically means that now you can understand what the embeddings that you just discovered and you didn't have any idea about are related to, or what kind of information they are compressing, and then use that for whatever purposes that you have in mind. So on one hand, this is kind of crazy useful because now you technically can convert embeddings from whatever model and to whatever downstream LLM word, and then use all LLMs for based on whatever embeddings. And this itself is crazy. But what frightened me when I first read about this paper was that people tended to think that if they have used an LLM to compress some data into the embedding space, that data is kind of de-identifiable and that the data is kind of encoded and saved from whatever kind of breach. And I also remember days that we were talking about in years of research that we had of yes, if we cannot share the data, let's use an embedding model to just embed the data and then share the embedding of that data. And guess what? That data is safe. Nobody can decode it. Nobody can understand what patient that embedding pool came from. But it seems like that nowadays you can easily decode the embeddings and understand what the original data was about, which has, as I said, a very important implication for the world of medicine, that data embedding is as valuable and as sensitive as the data itself. Now I pause here, Moein, because you also wanted to talk about this paper. I'm very curious to hear what you have to say about this.
Yeah, thanks just for sharing this. It was one of those papers that when I just read the title and abstract, I was like, "There's no way this could happen."
Yeah,
And
really.
it really blew my mind that
Mm-hmm.
they were able to do this. And we know that just putting the safety concerns aside, which are very important and really kind of like scary in some
Yep.
sense, just the usability of having this architecture or this methodology in place so that you can convert any of these spaces, vector spaces, into one shared latent space is just crazy. You can just compare two models together, or you can just see what would the representations of one model look like if they were converted to the another ones. And the methodology is also very cool. They use GANs basically to train those adapter layers to change these embeddings to the shared latent space. And I think there's a paragraph somewhere saying a conjecture that um, it was also very cool to look at the whole what neural networks do in that sense. And it was saying that um, we um, we are considering that all neural networks that are trained on the same
Oh.
modality and same language basically try to learn this shared latent space from the beginning. And based on the capacity and the training data and tokens they are able to learn this space in some sense to some degrees, but they probably can't because they don't have all the data available. But all these models, put them together, they're trying to learn the same embedding space, and they refer to it as that a strong platonic hypothesis somewhere in the abstract. I think I had highlighted something.
Do you want to share, or if you want,
No,
I can.
I think I can just show you where it was
Yeah, because it's
mentioned.
crazy.
But yeah, on page 3, the second paragraph.
Page 3, the second paragraph here.
At that part that is written in italic, neural networks trained with the same objective and modality, but with different data and model architectures, converge to a universal latent space, such that the translation between their respective representations can be learned without any pairwise correspondence. And this
Wow,
is
it's
also
crazy.
one of those scary and points about how neural networks are probably learning behind the scene, that they all converge to a shared representation space.
And Moein can be technically say that shared latent space or that shared embedding space is technically knowledge, right? Because we believe that each of these models is learning its own representation of the pure knowledge that is required to perform a task. And if you can figure out the common latent space for all of these models that have been trained with different data and architectures to do the same task, then you technically will arrive at the core pure knowledge required for doing that job,
Yeah,
right?
yeah, that's a very cool way to look at it. So
Crazy.
there is probably some shared latent space that all these data and knowledge are coming from, and these neural networks are just trying their best, given their capacity and the data they have access to just simulate that or learn some
Yeah.
part of it, but still in the same shape and same, yeah, overall architecture, which is really cool finding of this paper. And yeah, yeah, go on. And I think this is a
I think
very
this is a
exciting
very,
paper.
yeah, very, very exciting paper. Kudos to these authors from Cornell who actually put this together. Very amazing paper. And one of those work that when you see, you realize that, there are still lots of avenues to do research on deep learning that are far beyond the immediate, hot topic uh, avenues of LLMs nowadays, like, RL and fine tuning and all that stuff that are important. But there are some aspects that we are still far behind what we actually can do. And these kind of papers actually shed light on it. So very interesting one. And thanks for adding the context. And yeah, let's wait to see how embedding a space is going to change after this paper. I believe people now will start to work on this topic more and more. And hopefully we will reach to models that come out with their own adapters. And then, you can technically use, I don't know, for example, the OpenAI embedding model and with its own adapter so that you can later on, use it for whatever other LLMs that you like and just go there from it. I mean, it's interesting, very interesting.
Definitely.
All right,
And
so yeah, that is one paper. The other one that I wanted to talk about is, so this is a very quick one. I just want to share it very quickly. A new benchmark was dropped, Moein, Sudoku bench leaderboard. That's a cool benchmark. I mean, the name implies what it is. It technically is a benchmark to test LLM against Sudoku puzzles. And what it shows is that technically all of these models that we are now so proud of their intelligence suck so badly in solving Sudoku. And that technically means that we still have a long way to go if we really want them to achieve, a more than average human intelligence. We should be careful. I mean, average human possibly also suck in solving Sudoku, but this means that these models also do so. And then try to when they try to compare different models on their benchmark, they figured that basically neither of these models are smart enough to solve the 9x9 Sudoku table. Most of them can take care of the 4x4, but again, the performance varies significantly, and even a top-tier model like Gemini 2.5 Pro just does 60%, or maybe O3 mini high, 73.3%. But if you go to 9x9, zero for most of them. So these kind of benchmarks are from time to time heartwarming that we still have a long way to go. At that AGI, might not be that accessible. And maybe we need to come with new innovative benchmark from time to time to make sure that we are not overfitting to our own benchmarks.
yeah, and that's a good reminder that we're still not there, or we're probably missing some component to add to these LLMs
Yes.
so that they can handle different tasks than what they're used to do somewhat more easily, given the intelligence that they have.
Yeah.
So yeah, I mean, this was a cool benchmark.
Something cool, yeah. So, and then I have two. I mean, I picked two last things to talk about, and then I will be done with my list for today, and then you can go ahead. So, the first one is this concept of AI agent orchestration that came out of Microsoft. It goes back to a couple of weeks ago, as far as I remember, but the idea was kind of cool. They were saying that so this AI agent orchestrator is technically a team of AI agents. So they have put together a product, and that product gives you the capability to work with a team of AI agents rather than one single LLM. And those AI agents could be different, different kind of simulations of different key actors in a real medical world. So the example that they use, for example, is on a tumor board. Just imagine how the tumor board works in real life. They say that we can technically simulate the entire tumor board using our AI agent orchestrator. We do have an orchestrator agent that uses some of the Microsoft technologies behind the scene to develop the agents and coordinate them. Then there is one patient history agent behind the scene that is just analyzing the history obtained from the patient, the radiology agent that goes through the imaging data that we have available, and then use some of the fine-tuned models that Microsoft already has to interpret those images, the pathology agent that takes a look at the pathology, the cancer staging agent that technically does RAG and goes and explores some of the guidelines that are already available on staging of the tumors. And then again, another one that goes and checks clinical guidelines, or maybe goes and check the clinical trials to see if a patient can be recruited for any of the active trials. So it's kind of an interesting venue, right? When you look at it, definitely neither of these agents are mature at the moment. But even this example, or maybe even this demo of having an entire tumor board that is running by AI is kind of cool. Because as we go forward and each of these agents become more and more powerful, maybe one day we can really have a tumor board that is fully run by AI. And imagine that, rather than waiting for those, very high-level tumor boards to come up for a patient, technically you can have this for every single patient that you desire, and then not be that much of an expense. You can technically coordinate these as soon as you want to. And if you are just one provider taking care of the patient, before maybe reaching out to the entire real tumor board, you can at least seek AI help to go through the evidence and find out what the best could be for your patient, at least from the perspective of AI. And then when you go to the tumor boards, you have a little bit more, already explored a collection of information to present and seek the expertise of human board for a little bit more challenging stuff. So this is kind of interesting. And I'm not sure how much Microsoft is actually providing this as a full tool at the moment. I do think that people, or at least, if an institute has access to Microsoft Azure, they probably have access to this tool as well. But again, the main question is that how much of maturity this entire framework and each of these individual agents have. But again, a very interesting idea to spend a little time on and maybe have an eye on it, because probably more and more mature versions of that will come to the market as we go forward.
Yeah, definitely very interesting. And I think many of these sorts of examples we are seeing in this area recently, multi-agent systems for scientific discovery, multi-agent systems for simulating different roles in a physician team. And this one was really interesting. And I think one of those examples that can really help, because they can just dive into lots of guidelines and check so that nothing is missed.
Yeah.
And it's really difficult to imagine how or what parts of these systems will really remain and what parts will get replaced by newer technology.
Yeah.
But I think these agentic designs are probably one of those pieces that will stay with us for somewhat longer and will be useful in many areas of in medicine.
Yeah, I agree. I mean, we should wait and see how much of this actually becomes reality in future, but at least a cool ideation effort at the moment. And I also, at the end, I want to talk about the cherry on my cake, quoting Mr. LeCun, and I want to talk about this. Let me find that. This one. This is something that I believe is going to be very, very interesting. Have you heard about this, Moein? Neuronpedia, Anthropic?
No.
Okay, so this is cool. So the story is that Anthropic team technically released an open source tool named Neuronpedia, which is kind of a circuit tracer for LLMs. And at the moment, they are just providing access to one or two models that you can use for understanding. But the idea behind that is that you can technically rely on their tool to understand how an LLM thinks, right? It's kind of complicated to completely capture what kind of analysis you could do with these charts that they provide to you. They have kind of a user guide in the beginning. So if you go and open this website, definitely spend some time to just go through their examples and understand how you should use the tool. But I'm going to share my own very simple understanding of how these things work. And the point is not that it is not that complicated. So say, for example, you want to try it on a new prompt. And what I can do here is that, let's see if I can kind of get it started running Neuronpedia. I'm not sure if it is new graph. Yeah, like that. Okay, so you click on new graph. You come here, and what you can do is that you can technically just write a sentence that you want this LLM to complete for you. And then you are going to analyze how the LLM is doing that. Say, for example, the most common primary tumor of the brain is, and the way that you should work with this is that you should not ask it a question. They are technically analyzing the baseline model for you, which is a next token predictor. So you should you should format your prompt as a complete the sentence way. So here I have this sentence and I really expect it to say glioma or glioblastoma, for example. So I write the sentence in a way that one word is missing and that one word is going to be my answer. And it kind of guides you how to put together that. And it even asks you to remove any extra spaces and things like that. And then when you are done, it first shows you the thing that the model is going to present. So for example, the next token that it is going to predict, the most important one is going to be A, for example, or the GLI, that is possibly the starting for glioma, that is going to be the first one. Maybe I can just make my prompt a little bit better. The name of the most common primary tumor is primary tumor class. Common primary tumors of the brain, the class name. Now you see it's getting better, right? So now GLI is coming better. Oh, so it's saying that the next most likely token is white space. Then this technically means that my prompt is not good. So let's remove this class and go from there. And this technically should be glioma, right? Now you come here, you just give it some name. I just put test, for example. You can select which model you want to choose, but I guess at the moment they're just providing the capability to test Gemma 2 billion parameter model. And then you say start generation. Please choose a different one. Okay, so I should go with maybe Pouria test and then generating. Okay, so it's going to take about 30 seconds so that you can see what actually their analysis show. In a nutshell, it is going to show you the kind of features that the model is using for answering your question here. So while it is loading, you see here that here is the prompt that I put in. The name of the most common primary tumors of the brain is, and then this is the model that I'm taking a look at. And then you have different kind of graphs and subgraphs here. These one, on the main graph here, the x-axis is showing the words or the tokens of my initial prompt. And the y-axis is showing the different layers of this model. Say, for example, layer L13 and whatever. And as you see, this is kind of how neural networks work, right? They go from a lot of small features to kind of more high-level features that are more sparse, but more semantic rich. And then if you pick any of these ones here, say, for example, we are on layer 13, I believe. I just picked something. Let's pick another one that has no error in it. Because, okay, so this one looks like a good one. Sometimes it says that, this one, okay. Because they say that we still don't have the technology to understand what all these features mean. That's the reason for example, this ERR or error that you see here. This technically means that we could not decode this. But if you come here, for example, to this one, it's very interesting. It's showing that this is specific feature here that is coming out of layer 14, for example, I believe, is being enlightened by many of the previous features. And if you even go back by almost all of the words that I put in my initial prompt, and then when you look at this single one, you're saying that, hey, this feature is being more emphasized by some of the words that are actually coming from the core knowledge of the model. And it is kind of in disagreement with some other words from the model. Say, it's very difficult to interpret at the moment, but you see that at that point, the model is coming to the conclusion that the answer it is going to give back to the user has something to do with a stroke, with maybe method, with something with like researcher, URL connection, and nobody understands what exactly it is. And it definitely is different from these other words that you see here. It's kind of a Indiana Jones kind of decoding the knowledge of the model. And as you go forward, let's go to some of the higher layers. And say, for example, here, this is again like create tag helper, pop order, language, unused private. And as you go forward, okay, so I think I saw something more meaningful at least. Let's come here. Maybe, let's see. Maybe, no, not here yet. Let's see if we can find. So it's kind of interesting. We will find spots, or you will find features that look kind of more relevant to the task that you asked the model to work on. And then you kind of realize that if this model is moving towards the right direction or not. And a lot of times you might find words that is not that much meaningful. And for every feature, you see that, what kind of concept in the model's knowledge pool is empowering that feature to show up, or maybe not showing up. And see, for example, this Astro here, this is one of the outputs. It's not yet plotting the chart of that for me. But you hear that, you see that, what kind of words and what kind of phrases are kind of empowering that. It's very, very difficult to understand, right? I myself feel confused every time that I open it. I try to analyze a couple of sentences with that. And when you go to X and social media, people also have a lot of difficulty understanding it. But it is something. And, at least it's a step towards understanding these LLMs. And first of all, itself is very cool. I mean, if you just look at the application itself, is very cool. The second thing that really made me think about this is that I believe this is gonna be kind of the future of how medical providers should do or should act in a world full of AI. So when you tell people that, hey, AI will probably change your profession, if not replace it, and you as a doctor, for example, you are expected to do something different than what you have been doing so far, maybe a fraction of what people need to do in near or far future is something like this, that imagine a model that is looking at many radiology papers, many radiology imaging, and maybe the EHR data of the patient, and then is predicting something for you. And you, as the one who has the domain expertise, now need to go a little bit behind the scene. And if you are in doubt about what the model is saying, you need to come and investigate these layers and try to understand what this model has been doing to denote whether or not we can rely on what the model is predicting. And again, a very, very difficult job to do. Probably the final application, or maybe if you go 1 year ahead, the user interface of such interpretability tools are going to be much better. But even this one is very cool. I mean, imagine 2 months ago, we technically had accepted that the inside of these LLMs is a black box and we know nothing about it. But now we can come here, we can think about the different features, maybe evaluate them a little bit, understand if something is relevant or not relevant. And if we went and studied all of these features, maybe we could connect the dots and figure out, all right, so maybe this was the path that the model took to finally give me the glioma answer. And it is very cool. So that was the most interesting thing I had to share for this week. And I pause here. Moein, feel free to comment on this one or move along with your own topics.
And thanks for mentioning it. I had totally missed this on my radar. And yes, it's difficult to work with at the moment. But as you said, it's something there to say that, okay, these models are not that black box, and we can dive deeper into where the connections are coming, or how these attentions are probably helping to separate some embeddings from the others, and know that the model is probably looking at the right area in the embedding space to see how they came up with the final answer. And yes, I think the user interface needs a lot. There's a lot of room to improve for the user interface. And it's really difficult to make such an application, basically, to as you were showing the words that the model was mentioning, that was positive and negative one, they were kind of we don't have many ways to understand how these different positive and negative weightings are helping the model, but probably having a bigger picture or some methods on summarizing all these points that uh, this interface is sharing probably helps to understand the bigger picture, that where the model is looking at to come up with the final answer.
Yeah.
And this reminded me of a long blog post by Anthropic
Mhm.
called "On the Biology of the Neural Networks" or Large Language Models, I think.
Yeah,
And
something like that. That they talked about that San Francisco Bridge and stuff.
yeah, I think it was a bit different from. I mean, it was released recently, and it is a continuation of the works that was done, yeah, on the San Francisco Bridge, the example there. And let me send. I don't know if you
Yeah,
wanted to share the screen
yeah.
or.
Definitely. I guess you can go ahead and share your screen because I'm done with my topic, so I guess
Okay.
that might be easier. So let me stop sharing.
So I briefly mentioned this one here, but Uh, as I read it a long time ago, I don't remember much to explain here, but the title is this one, "On the Biology of a Large Language Model." And one of the examples was a medical diagnosis. It was there's a whole case given to the model, and uh, the model came up with the diagnosis of preeclampsia, and they were then going analyzing the embeddings of the similar examples in the data sets that probably help the model come up with
Mhm.
this answer. And as you see, the model is able to pick up the themes, and
Mm,
they finally proposed this kind of like the flow charts that the model
yeah,
probably came up with. And yeah, I think this is also a cool way that
yeah.
the researchers are found to analyze how the models come up with answers.
I guess
Uh,
more in the technology behind that tool that I showed, and this paper is kind of the same because when I was going through the Twitter posts about this new tool, a lot of the diagrams that people had plotted there were very similar to the one on this blog post. So I guess that's a simplified version of what that tool is showing us.
mhm. Yeah. So I stop here because I don't remember the exact nuances they were introducing in
Uh,
this blog post to share here, but the audience can just go read it for themselves. And it is a long blog post. There are many
yeah.
themes that they have covered. So just a few quick mentions before we
Sure.
wrap up this episode. Was I wanted to introduce this paper. Yeah, this was the same one and that you mentioned. This paper was also interesting. The absolute, the absolute zero paper, which
Are you showing that Moin to us? Because I'm not seeing it yet.
oh, I think I probably shared the
Yeah, you probably
tab,
shared
not
the
the
tab. I
window.
don't. Okay,
Yeah,
yeah.
let me share the whole window. Okay, so yes, this was the paper called Absolute Zero Reinforced Self-Play Reasoning with Zero Data, which is a really cool idea of how they approach this problem. And is that I think this is, we can think of it as a next step of the method that DeepSeek paper introduced, the GRPO algorithm, and they used reinforcement learning on math and coding tasks to improve the reasoning capabilities of these large language models. But this paper adds to the previous one in a way that now they don't require human generated data like those mathematics and coding databases and datasets that they were used for reinforcement learning. And now the model comes up with the mathematical or the coding task itself and then learns to solve that task. And just by this way, by kind of like self-playing with itself, improves the knowledge of the math and coding. And I think the figure that helps to understand this probably is this. So the model now does not have any, they start with a pre-trained large language model, like, for example, the base model of it, the ChatGPT, or the core pre-trained model that is not post-trained yet. And they want the model, they design a loss function that helps the model first design a task, like, for example, it could be an abduction task, which the model first generates some outputs and some program, and then it needs to generate the inputs that leads to that output given the program. So it basically generates the question, the problem itself, and then solves it, and gives itself two sources of rewards, which is one, the learnability of that task, how much that task helped the model improve its understanding and its knowledge about coding and math, and if the final answer was right or wrong. And they showed that this method helps in post-training many of the available open source models. They added, there is, I think, a table here, yes. They fine-tune llama models with this approach, and as you see, there's a very significant change and increase in performance. They also fine-tune the Quen models using this approach. And I think this is a very sustainable way to fine-tune the models, because there is no limit to it. There is no human data needed, and the model both designs the tasks and then solves them, and has the capability to validate whether the response was right or wrong, because it's code and math, and you can verify them using a terminal or using a code interpreter. So and this is helpful. The problem or the challenge still is that this is limited to code and math, where there is an environment where you can verify the answers in a programmatic way. You don't need a human evaluation or something. And they didn't show that this method helps in reasoning in the general domain questions. Most of these benchmarks are, again, related to code and math, which makes sense. But the authors mentioned that the next step would be to find similar solutions for general domain questions and data sets. So this was one cool paper that I read, during the last months. The other one was a tool to search archive a bit more effectively using, it's a semantic search engine, so it's like a Google just for papers on archive. This is not very accurate to the terms that you put in the search bar, but it's still, it's a good user interface to have over archive. So I just wanted to give a quick mention of it.
It basically does RAG with archive, right?
Yeah, probably something like that. I don't know what's the code behind it or how it works, but I think it should work probably in that way. And there's also a cool blog by a person called Maxwell Forbes that I found. I tend to introduce someone in some of these episodes, and this is again one of those blog posts. And I got introduced to this by this very interesting post, how to get your paper accepted. And this is not something, it's not advertising some shady things to do to just get your paper accepted. Just an intro to how to design your paper, how to put different things in place so that it's very interesting for the reviewers and still to the point, and something that adds something to the literature. And I really like the text here, and most of the points that he was mentioning was novel. I hadn't read before or heard about somewhere else. and very to the point, and it was really helpful.
This is
So
very nice one. I like the idea that page one accepts, the rest refuses, rejects.
exactly,
That
yeah,
is kind of very
that,
interesting. Yeah.
and this is more towards the technical and coding
Engineering
papers
kind of
rather
papers.
than
Yeah,
medical papers, but there are many common themes I think that people
definitely.
use. And there's also a good blog post from this person on creating figures. I mean, these are sorts of things that are really necessary to know, but before these, I didn't have a good resource to introduce to people so that they can read and learn more about these topics. And it's really nice that this person is writing about this stuff. And let me see what else I wanted to cover. I think I'm done here, and yeah, we can probably wrap up this session.
Yeah, thanks for sharing all of this, Moin. The last slide you showed reminded me of another paper that came out. I didn't include it because we talked about something similar, I guess, last meeting we had together as well, and that was a model that actually generated a poster out of a given paper.
Yes, I
So yeah,
remember.
another one of those came out as well. So it seems like that we are moving towards that direction, that you can technically rely on AI for taking care of the presentations, hopefully figures and things like that. But I do think that there's still a lot of role for humans to understand what these models are doing and trying to correct them as needed. Anyhow, yeah, thanks for today. I guess what we talked about today were mostly a collection of very good steps in right directions, but it's still not adequate steps. So I guess the benchmark from OpenAI that you introduced was like that. The tool from Anthropic to unveil the black box of deep learning was like that, and many other ideas like this as well. So we talked about a lot of things that have potentials for future. Hopefully someday soon we can see the full picture of them as well. But again,
Yes.
thanks a
Yeah.
lot. Yeah, and hopefully we can talk about many more cool things next month as well.
Yeah, and thank you for sharing all the cool and interesting items that you had on your list. And yeah, I also think that we still need some time. I mean, the companies behind these innovations to come up with the final solutions to these problems. And this is a probably a long way, but yeah, there's lots of progress being made in this space.
Exactly. All right.
Uh,
Thank you all for watching us today, and we will be back hopefully in about a month or even quicker than that. Goodbye.
yeah. Goodbye.
Goodbye.